What if I told you that the future of transportation might not be what you think? While everyone's talking about electric vehicles, there's another technology quietly gaining momentum that could change everything. And no, I'm not talking about flying cars or teleportation. I'm talking about something that sounds almost too simple to be true. Cars that emit nothing but water vapor. Sounds impossible, right? Stick around. Because what you're about to discover might just blow your mind. The automotive world has been buzzing lately with rumors about major manufacturers exploring alternatives to traditional battery technology. We're seeing a shift that nobody predicted just a few years ago. Companies that built their entire reputation on lithium-ion batteries are now looking at hydrogen fuel cells with fresh eyes. Why? Because the challenges of mass-producing next-generation batteries are proving harder than anyone anticipated. Production bottlenecks, supply chain issues, and sky-high costs are forcing industry leaders to reconsider their strategies. But before we dive into what's happening now, let's rewind and look at how we got here. The electric vehicle revolution didn't happen overnight. It started with a dream that seemed crazy at the time, convincing the world to ditch gasoline and diesel for electric power. Back in the early 2000s, most people thought electric cars were golf carts with delusions of grandeur. Slow, boring, and utterly impractical. But a group of determined engineers believed otherwise. They saw a future where electric vehicles weren't just viable, but desirable. When a certain visionary entrepreneur threw his weight behind this mission, everything accelerated. Money helped, sure, but it was the bold vision that really changed the game. The goal wasn't just to build electric cars. It was to build electric cars that people would actually want to drive. Fast cars, sexy cars. Cars that made gasoline engines look ancient by comparison. And that's exactly what happened. The first breakthrough came with a sports car that shocked the world. Built on a lightweight chassis, this all-electric speedster proved that electricity and performance could coexist. When people saw it accelerate from 0 to 60 in under 4 seconds, jaws dropped. This wasn't your grandma's electric golf cart. This was a statement on wheels, screaming one message loud and clear: the future doesn't run on fossil fuels. After proving the concept, the next move was bold: enter the luxury market. The premium sedan that followed became a game-changer. With incredible range, cutting-edge technology, and self-driving features that seemed straight out of science fiction, it forced the entire automotive industry to take notice. For the first time, an electric car wasn't just an eco-friendly compromise. It was actually better than its gas-guzzling competitors. Then came the SUV with doors that opened like wings. Futuristic doesn't even begin to describe it. Legacy automakers who'd been building cars for decades suddenly found themselves scrambling to catch up. The design language, the technology integration, the sheer audacity of it all forced everyone to rethink what a car could be. But the real revolution happened when affordable models hit the market. This is when electric vehicles stopped being toys for the wealthy and became options for everyday people. By keeping prices accessible while refusing to compromise on technology or performance, these vehicles democratized the electric dream. Suddenly, choosing electric wasn't about making a sacrifice for the environment. It was just making sense. The family-friendly SUV that launched around 2020 sealed the deal. Within a couple years, it became one of the best-selling vehicles on the planet. Not just the best-selling electric vehicle, one of the best-selling cars, period. That's when everyone knew this wasn't a trend. This was a fundamental shift in how humans move from place to place. The success came down to changing perceptions. For years, people believed electric cars were limited by range anxiety, charging hassles, and weak performance. But by building an extensive fast-charging network and pushing battery technology to new limits, these concerns evaporated. When vehicles could travel over 400 miles on a single charge and recharge to 80% in 30 minutes, the excuses disappeared. Electric wasn't just eco-friendly anymore. It was practical, powerful, and pretty damn cool. But here's where things get interesting. Right now, at this moment, we're standing at another crossroads. The same companies that convinced the world to go electric are facing new challenges. Those next-generation battery cells that were supposed to revolutionize energy storage, they're proving incredibly difficult to manufacture at scale. The costs are higher than expected. The production process is more complex than anticipated. And that's opening the door for alternative technologies to enter the conversation. This brings us to hydrogen. Now, before your eyes glaze over, let me make something crystal clear. I'm not talking about pouring water into your gas tank and driving off into the sunset. That's not how any of this works. Water itself has zero energy. It's not a fuel. It's what happens when hydrogen and oxygen get together and have a party. So how does this actually work? The process starts with something called electrolysis. Sounds complicated, but it's actually pretty straightforward. You take water, which is H2O, and you run electricity through it. This splits the water molecule into two parts, hydrogen gas and oxygen gas. The hydrogen gets stored in special tanks. When you need to drive, that hydrogen goes into a device called a fuel cell. Inside the fuel cell, hydrogen meets oxygen again, and boom, they react, producing electricity. That electricity powers the motor. The car moves, and the only thing coming out of the tailpipe? Water vapor. That's it. No smoke, no carbon dioxide, no pollution. Just water. Some folks call this reverse electrolysis, but that's just a fancy way of describing the same fuel cell process that scientists have understood for decades. You use electricity to split water and get hydrogen. Later, you use hydrogen to create electricity. It's a loop. A clean loop, if done right. Now let me address the elephant in the room. Has any major automotive company officially announced they're building water engines? Not in those exact words. But here's what we do know. Research into sustainable energy alternatives is happening right now, behind closed doors, in laboratories around the world. And hydrogen fuel cells are a major focus of that research. Think about it. Hydrogen is the lightest element in the universe, but it packs serious energy density. A small amount can generate a lot of power. If you can produce it cleanly and store it safely, you've got yourself a legitimate alternative to gasoline. Some manufacturers have already figured this out. Japanese and Korean companies have been selling hydrogen fuel cell vehicles for years. These aren't concept cars. They're real vehicles you can buy today, driving on real roads, emitting nothing but water vapor. So why is interest in hydrogen growing right now? Simple. Battery technology, despite its massive improvements, still has limitations. Manufacturing challenges, supply chain constraints, environmental concerns about mining rare metals. These issues aren't going away overnight. Meanwhile, hydrogen offers a different path forward. Not necessarily better in every way, but different. And in technology, having options is never a bad thing. Here's what a clean energy loop looks like. You generate electricity from renewable sources like solar panels or wind turbines. You use that electricity to split water and produce hydrogen. You store that hydrogen. When you need energy, the hydrogen generates electricity through fuel cells, powering vehicles or buildings. The byproduct, water, which can be split again. No carbon emissions anywhere in the cycle. That's the dream. That's why scientists get excited about this stuff. But let's pump the brakes for a second and talk reality. How does hydrogen actually stack up against other technologies? Where does it fit between electric batteries and traditional combustion engines? Let's break this down with some hard numbers. Traditional gasoline and diesel engines are embarrassingly inefficient. They convert only about 25 to 30% of fuel's energy into actual movement. The rest? Wasted as heat and noise. That's why they burn through so much fuel and pump out so much pollution. It's like using a sledgehammer to crack a nut. Sure, it works. But there's got to be a better way. Electric vehicles are the efficiency champions right now. The electricity stored in batteries goes directly to the motor with minimal loss. We're talking 85 to 90% efficiency. Almost all the energy you put in actually moves the car. That's why EVs can travel hundreds of miles on a relatively small amount of electricity. It's also why they're becoming so popular. Better performance, lower operating costs, zero emissions. It's a winning combination. Hydrogen fuel cells typically last for several 100,000 kilometers before needing replacement. When they do fail, replacement costs less than a battery pack. Degradation is slower and more predictable. Over a vehicle's lifetime, maintenance costs for hydrogen systems might actually beat batteries. But here's the kicker. Right now, hydrogen vehicles cost between $50,000 and $70,000. That's a lot of money. The high price reflects limited production volumes, expensive fuel cell technology, and minimal infrastructure. But remember how expensive electric vehicles used to be? Prices dropped dramatically as production scaled up. The same will happen with hydrogen. According to energy experts, if green hydrogen production increases significantly over the next decade, prices could fall by 50% or more. As fuel cell manufacturing improves and economies of scale kick in, costs will come down. Here's an interesting fact. 1 kilogram of hydrogen contains roughly the same energy as 3 liters of gasoline. Right now, hydrogen is expensive because production is limited and inefficient. But if we start producing it from renewable sources at scale, it could actually become cheaper than gasoline. And since refueling takes just minutes, it becomes incredibly practical for commercial vehicles that need to maximize uptime. So where does this leave us? Are we really looking at a future where cars run on hydrogen? Or is this just hype? The truth is somewhere in the middle. Hydrogen technology is real, proven, and already on the roads in several countries. It's not science fiction, but it's also not ready to replace everything tomorrow. The infrastructure needs massive development. Production methods need to become greener and cheaper. Safety systems need refinement. Public acceptance needs to grow. What we're likely seeing is the beginning of a diversified transportation future. Electric vehicles will continue dominating personal transportation, especially in urban areas where their efficiency and convenience shine. Hydrogen will find its niche in long-haul trucking, buses, trains, and maybe personal vehicles for people who regularly drive long distances. Industrial applications like powering ships or generating electricity might benefit enormously from hydrogen. The key insight is this: we don't need just one solution. We need multiple clean technologies working together, each suited to different applications. Battery electric for short trips and daily commuting. Hydrogen for heavy-duty vehicles and long-distance travel. Together, these technologies can help us transition away from fossil fuels and toward a cleaner, more sustainable future. The automotive industry is changing faster than most people realize. Technologies that seemed like fantasy a decade ago are now reality. What seems impossible today might be commonplace tomorrow. Whether it's called a water engine, a hydrogen fuel cell, or something else entirely, the underlying principle remains the same: finding cleaner, smarter ways to power our vehicles and our lives. The question isn't whether change is coming. Change is already here. The question is how quickly we adapt, how boldly we invest in new infrastructure, and how willing we are to embrace technologies that might seem unfamiliar at first. So what do you think? Are hydrogen vehicles the missing piece in our clean energy future? Or will batteries continue to dominate the road ahead? Drop your thoughts in the comments below. I'd love to hear what you think about all this. And if you found this deep dive valuable, show some love by hitting that like button. Subscribe if you want more honest, in-depth looks at the technologies shaping our future. No hype, no clickbait, just real information you can actually use. Thanks for watching, and I'll see you in the next one. Hydrogen fuel cells sit somewhere in the middle. They convert hydrogen to electricity at about 55 to 60% efficiency. Not as good as batteries, but way better than combustion engines. The advantage? No emissions. The disadvantage? You lose some energy in the conversion process. Still, for certain applications, that trade-off might be worth it. Cost is where things get complicated. Combustion engines are cheap to manufacture because we've been building them for over a century. But maintaining them? Expensive. Fuel costs fluctuate wildly, and the environmental damage they cause carries its own price tag. Electric vehicles cost more upfront mainly because batteries are expensive, but running costs are incredibly low. Charging at home might cost a fifth of what you'd spend on gasoline. Over the vehicle's lifetime, you save serious money. Hydrogen vehicles are currently the most expensive option. Why? Because producing, storing, and distributing hydrogen is complex and costly. But here's the thing. Every new technology starts expensive. Remember when flat-screen TVs cost $10,000? Now they're practically free. As production scales up and technology improves, especially if we start producing hydrogen using renewable energy, costs will drop dramatically. Let's talk about the practical stuff that matters to real people. Refueling time? If you drive an electric vehicle, charging takes time. With a fast charger, you might hit 80% in 30 minutes. With a standard home charger, you're looking at several hours overnight. It works fine for most people's daily routines, but it's not instant. Hydrogen refueling takes 3 to 5 minutes. Pull up, fill up, drive away, exactly like a gas station. For people who regularly drive long distances or need to get back on the road quickly, that's huge. It's the convenience of gasoline without the guilt. Range is another consideration. Modern electric vehicles can travel 400 to 600 kilometers on a full charge. Hydrogen vehicles can push 600 to 700 kilometers. Some models exceed 650 kilometers. That's comparable to gasoline cars and slightly better than most EVs. For long-haul trucking or commercial vehicles, that extra range matters. But here's where we need to talk about the real environmental picture, because it's not as simple as hydrogen good, everything else bad. Traditional combustion engines are environmental disasters. They pump out carbon dioxide, nitrogen oxides, and other nasty pollutants that contribute to climate change and air pollution. No argument there. Electric vehicles produce zero tailpipe emissions, which is fantastic. But the batteries require lithium, cobalt, and nickel. Mining these materials causes environmental damage. And if the electricity charging those batteries comes from coal plants, the environmental benefit diminishes. EVs are still cleaner overall, but they're not perfect. Hydrogen fuel cells emit only water vapor. On the surface, that's amazing. The catch? About 95% of hydrogen produced today comes from natural gas, releasing carbon in the process. This gray hydrogen isn't much better than gasoline from an environmental standpoint. The real promise lies in green hydrogen, produced using renewable energy. That's the holy grail. Zero emissions from production to use, but we're not there yet on a large scale. So electric vehicles are the cleanest option available today, especially as electricity grids become greener. Hydrogen could become even cleaner in the future if production methods improve. Combustion engines are yesterday's technology, slowly but surely becoming obsolete. And hydrogen? It's the interesting middle ground. Cleaner than gasoline, faster to refuel than batteries with good range. If production goes green, it could be truly sustainable. The future likely isn't either or. We'll probably see electric vehicles dominating short-distance urban transportation, while hydrogen powers long-haul trucks, buses, and commercial vehicles. These technologies complement each other rather than compete. Together, they can help us reach the goal everyone's talking about: net zero emissions. Now, I know what you're thinking. If hydrogen is so great, why isn't everyone driving hydrogen cars already? Great question. Let's talk about the very real challenges standing in the way. Challenge number 1, infrastructure, or rather the lack of it. Right now, you can find charging stations in most cities. Gas stations are everywhere. Hydrogen refueling stations? Extremely rare. In the United States, they're mostly concentrated in California. Europe and Japan have made more progress, but the network is still tiny compared to what's needed. In many countries, you can count hydrogen stations on one hand. Building this infrastructure requires billions of dollars and years of effort. Challenge number 2, storing hydrogen safely. Hydrogen is light, but it's also highly flammable. Storing it requires incredibly strong tanks that can handle massive pressure, often up to 700 times atmospheric pressure. That's way more than a regular gas tank. A leak could be catastrophic. Companies working with hydrogen use advanced carbon fiber tanks tested under extreme conditions, but public fear remains. One small spark and hydrogen can ignite. Even worse, hydrogen flames are invisible, making accidents harder to detect. Building public trust isn't just about engineering. It's about transparency. Companies need to show people exactly how safe these systems are, what testing has been done, and what safety measures are in place. Without trust, adoption won't happen, no matter how good the technology is. Challenge number 3, the cost of infrastructure. Building a single hydrogen refueling station costs between $1 and $2 million. Compare that to an EV charging station, which costs about a tenth of that amount. You also need pipelines, storage facilities, and distribution networks. The investment required is massive. Some governments are stepping up with funding, particularly in Japan, Germany, and South Korea, but progress is slow elsewhere. Challenge number 4, regulatory hurdles. Every country has different safety standards for handling hydrogen. Europe has strict regulations about purity, pressure, and safety systems. The United States has its own requirements through various federal agencies. Before any new hydrogen vehicle hits the market, it must pass extensive testing and receive multiple approvals. This process can take years. Red tape isn't sexy, but it's a real obstacle slowing down adoption. Let's also address the environmental question more directly, because there's a lot of confusion here. People hear water engine and think problem solved. But the reality is more nuanced. Right now, the average gasoline car releases about 4.6 metric tons of carbon dioxide every year. That's equivalent to what 200 trees can absorb annually. Multiply that by millions of vehicles, and you see why transportation is a major contributor to climate change. The transportation sector accounts for roughly 25% of global carbon emissions. Cleaning up how we move people and goods could make a massive difference. If hydrogen is produced from renewable sources, the emissions could drop to nearly zero. Hydrogen fuel cells emit only water vapor. No carbon, no pollutants. A car that used to emit 4.6 tons of CO2 annually would produce nothing harmful. That's the promise. But here's the uncomfortable truth most people don't talk about. Almost all hydrogen produced today comes from natural gas. The production process itself releases carbon. So if you're just switching from gasoline to gray hydrogen, you're not solving the problem. You're just moving it around. The real environmental benefit only comes with green hydrogen, produced using solar, wind, or hydroelectric power. And we're not producing nearly enough of that yet. Electric vehicles also face environmental challenges. Mining lithium, cobalt, and nickel tears up the landscape and pollutes water sources. Battery recycling is still in its infancy. If not done properly, spent batteries become a new environmental problem. Hydrogen systems don't require extensive mining, but producing and storing hydrogen requires significant energy. The question is where that energy comes from. The path forward requires massive investment in renewable energy. If we can produce abundant clean electricity from solar and wind, we can use that electricity either directly for EVs or to produce green hydrogen. Both paths work. Both have advantages in different situations. Let's talk money, because that's what ultimately determines whether technology succeeds or fails. How expensive are hydrogen vehicles? What does maintenance cost? And can regular people afford them? Hydrogen fuel cell systems have far fewer moving parts than traditional engines. No pistons, no crankshafts, no timing belts that need constant maintenance. A chemical reaction produces electricity which powers a motor. That's it. Simpler means more reliable. Less maintenance, lower long-term costs. Compare this to conventional engines with hundreds of moving parts, all wearing down through friction and heat. Oil changes, filter replacements, major repairs. It adds up quickly. Fuel cell engines largely avoid these headaches. Battery electric vehicles also have low maintenance, since electric motors are simple and reliable. But batteries themselves degrade over time. After 8 to 10 years, capacity drops noticeably. Replacement batteries cost tens of thousands of dollars, sometimes approaching half the original vehicle price. That's a serious expense many people don't consider when buying an EV.